So now that we've spent time with our basic inference rules, which, by the way, it's a really good exercise to go through that table 1 in Rosen 1.6.3 and reprove for yourself in a variety of different ways that each one of those is true. But in any case, now that we know that, let's go ahead and try to put that into practice. We're going to put that into practice by verifying an argument or a proof. And usually when an argument is presented to us, it doesn't come in that nice little tabular format with P's and Q's and implications and stuff like that. It comes to us as an English statement. So let's go ahead and consider an argument and try to verify whether it is valid or not. So here we have our example, and I want to figure out if this is a valid argument or not. If I code when I'm tired, then I will make mistakes. If I make mistakes, then my code will fail continuous integration tests right here. So that suite of tests to see whether or not your code is correct and passing all the tests. And the claim of this argument, or the conclusion, is therefore, if I code when I'm tired, my code will fail the continuous integration tests right here. And so we want to see how can we apply our inference rules to verify whether or not this is a valid argument. So the very first thing that we're going to have to do is take this English paragraph right here and translate it into symbols. So in this particular translation, I'm going to let P be the proposition I code when I'm tired, because I see that right here between an if statement right here, so I know that it's a good candidate to be one of my propositional variables. Q be the statement or proposition I make a mistake in my code. And lastly, R is going to be my code fails to pass the continuous integration tests right here. So I've introduced these propositional variables right here, and so we can translate this English paragraph into something that actually looks like one of the arguments back when we were talking about inference rules. So in particular, translating this, well, let's see here. These first two sentences right here, those are my hypotheses. And this over here is my conclusion. So let's consider our first hypothesis. If I code when I'm tired, then I will make a mistake. Code when I'm tired, make a mistake. So our first hypothesis is going to be P implies Q. My second hypothesis, if I make mistakes, then my code will fail the CI tests right here. Well, that's if I make a mistake, code fails to pass continuous integration tests. That's Q implies R over here. And then the last therefore right there, that's the claim, that's the conclusion. If I code when I'm tired, then my code will fail the CI tests. So P implies R. So fantastic. I've been able to take this English paragraph and translate it to something that looks like one of those arguments back when we were talking about our basic inference rules right here. And so I want to verify whether or not this is a valid argument. And if I had spent a lot of time with table 1, I might immediately recognize that, oh yeah, this thing right here is called a hypothetical syllogism. And yes, this is a valid argument right here, therefore that English paragraph is a valid argument. But let's say I haven't remembered that this thing right here is a valid argument, and I haven't remembered the name hypothetical syllogism. Let's go ahead and verify quickly that this is a valid argument. And we had 3 different ways to do that, right? So one way was that we could use our rules of logic to be able to show that this and this implies that is a tautology. Or I could use a truth table to show that that same thing is a tautology. Or I could simply go back to my definition of what a valid argument is. And remember, that means I'm considering the case when all my hypotheses right here are true, and see if that implies that my conclusion right here is true. So let's quickly write down truth tables for P implies Q, Q implies R, and see if that's going to imply that P implies R over here. And I remember my definition of the truth table for implication right here. The only time it's going to be false is right here, and it's going to be true otherwise. We have another hypothesis right here, which is Q implies R. And again, I can quickly fill in this truth table here. Great. I have my hypotheses. My definition of a valid argument is I consider setting these equal to true and see if that implies that my conclusion here is true. So I want to set my hypotheses to true. So if I set my hypotheses to true, well, that's one of my hypotheses, and it's true right here, and it's also true here, and it's true here. So I'm really only considering these 3 rows in that particular truth table. My second hypothesis, this Q implies R right here, I want to set that equal to true, and that is, well, it's the same. I'm considering these 2 rows and that row right there. And what I want to verify is whether or not in these boxed cases right there, this P implies R is true. So if we write So I know my hypotheses here, I want to be considering the cases where they're true, so only those particular entries right there. So to figure out whether or not my conclusion right here, P implies R, is true, I only have to consider certain values of P and R. So indeed, P over here, let's consider the first one, P could be true. Well, if P is true, that means in this particular row, Q is true. So that means that R would also be true. So I have to consider true and true right here. P could also be false, right? Because I'm considering these couple of rows. And in that case, Q could either be true or false. So Q could be true or false. And in that instance, R could then either be true or false. So I know I have to consider R being true or false, in this case when P is false right here. So remember, I'm taking my hypotheses right here. I'm only considering the case when they are true. That helps me figure out what values of these variables, P and R, are going to have to be. So then I need to verify whether or not my conclusion is true. And let's see here. True implies true. Yes, that is a true statement. False implies true. Yes, that's a true statement. And false implies false. That is also a true statement right here. So fantastic. If I set my hypotheses all to true, then my conclusion is also always true. So even if I didn't remember hypothetical syllogism right here, I was very quickly able to conclude that yes, this here is a valid argument. And I can say that this example right here is valid. And so if you're presented with this problem, you could either say yes because of hypothetical syllogism, or yes because I actually proved it myself.